Welcome to Lecture 3, Part 2. In this lecture, I will be talking about building energy, category, conversion efficiency, calculating energy use in buildings, and building energy intensity. At the outset, building energy use can be classified into three main categories. First is the primary energy, is that contained in fossil fuels, coal, oil, or natural gas. These are the raw energy that can be found in nature. And then this energy are delivered, and it is called delivered energy, is that in the fuel at its point of use after allowing for extraction, generation, and distribution. This is when the natural resources are being brought to processing plant and power plant to generate power. And then the final form of the category of energy in a building is useful energy. This is the proportion of the delivered energy which is of benefit after allowing for efficiency of the consuming appliance. To get a better picture of all these categories, this is the chart. We started off with raw fuel. For example, in this case, coal. When you take it out, the energy that contained therein would require some energy for extraction. You use machine to extract coal from the earth, and then you transport it to the power plant. So some of the energy is lost because energy being used by the extraction and transportation process itself. And then these are supplied at the power plant, where it is being burned to run the turbine or whatever mechanism to produce the required electrical power. And when it is distributed throughout the network, national network, to go into houses and buildings, a lot of it are lost in the delivery, in the transformer, in the cables that are used to bring electricity throughout the nation. Some 30% are lost. And then finally the energy that is supplied to the appliances from your homes, already about 29% of it is left, is lost from the conversion of the electrical energy to useful energy. Useful energy means that you get the light, you get the cooling from air conditioning, you get the movement of escalators. These are useful energy. So the conversion efficiency of the system can be shown by this formula, that is the useful energy output divided by total energy input. So you get the efficiency. So it's very difficult for you to get 100% efficiency, because like I said, there will be energy loss in transportation, in conversion, in producing electricity. You convert from chemical energy in coal, and you burn it, it turns into heat. Some of these are lost, the heat are lost, even if there are some flames, it is being converted into light, and eventually the hot water in the turbine is being converted into kinetic energy. At each step of this conversion, some of the energy are lost. So this is an example of how we can calculate the energy loss and the efficiency of electrical energy that is transferred to a building. We start off with 1 ton of coal, that is about 28 gigajoule. And in mining and transportation, you lost about 2.5% of it. So what is left is about 97.5%, leaving the power stations. Okay. You get 27.3 gigajoule. And then the power station itself, if they use modern coal-fired turbine, the efficiency is about 35%. So that the energy leaving the power station is only 35% of that 27.3, and you get 9.56 gigajoule. 7.5% transmission loss in wires and transformers along the way. And then the electrical energy, what is left is about 8.84 gigajoule. And then the efficiency of incandescent light bulb. This is the old uh, light bulb that used to be orange in color and produce a lot of heat. The efficiency of converting that energy to light is only 5%. Lots of it are lost as heat. So the useful energy is about 5% of that is 0.44 gigajoule. So if you do the calculation, the overall energy efficiency stands to about 1.6%. Therefore, it is very important for us to increase efficiency in whatever way, whether delivery, whether transportation, or whether energy efficiency appliances being used. This will help a lot. Okay, now we talk about electricity that is used in buildings. Okay, this is how you calculate the energy. I have discussed before that we can use BTUs, British Thermal Unit. We can use joules. We can use calorie to calculate energy. But the standard way of calculating energy use in a building is watt. Okay. So normally when you purchase appliances, it will show the power rating. Normally the number that is followed by the word W, the letter W. Okay. And 1 watt is 1 joule per second. For example, a light bulb has the power rating of 50 watt. That means it used 50 joules per second. In 1 hour, the bulb has used 50 times 3,600 seconds, and you are using about 180,000 joules. Or we can say the energy used by the bulb in 1 hour is 50 watt times 1 hour, 50 watt hour. That is another way of saying it. Instead of using joules, you use watt hour. So watt hour being used in denoting energy used in buildings is the normal way of how we denote energy being used in a building. And normally the energy being used are in the order of thousands. So we use 1,000 watt hour and turn it into 1 kilowatt hour. So that is the normal way of indicating how much energy is being used in a building. Now we have understood the unit of measurement or the scale of measurement used in a building. We can move on to another concept in building energy, that is building energy intensity, or BEI. BEI is the amount of energy used by a building in a year. So the bigger the building, of course, the more amount of energy being used in a year, but you normalize this by comparing the amount of energy used per square meter. Okay? So BI is basically the amount of energy used by a building in a year per square meter, and the unit is kilowatt hour per meter square per year. It is a benchmarking tool in monitoring building energy performance by indicating the intensity of energy used per meter square of the building. The index is calculated by taking the ratio between annual energy consumption of a building and net floor area of the building. Notice that the size of the floor being used is net floor area. So normally this will exclude parking and the energy used for outdoor lighting when you have car park or other landscape area at night. So this will be excluded in the calculation. So the formula is shown there. BEI is the annual energy consumption in kilowatt hour per net floor area in meter square. Once you have this concept of comparing building energy intensity, energy use between different buildings, then you can start to do benchmarking. Suruhan Jaya Tenaga, the council that is responsible for the energy use in buildings, have introduced a star rating concept to benchmark between different buildings. They give 5-star for buildings whose energy intensity is less than 100 kilowatt hour per meter square per year, and the star goes down as the amount of energy used per square meter increases. So if you have let's say BEI of 300, you will get just 1 star. Most of Malaysian buildings, I think the data from 5 years ago, the BAI, most of them are above 250. That's why they are given 1 star. By right, they shouldn't be given any star if they used energy excessively. But I suppose by just doing an energy audit to establish the number, I mean they did a calculation, they did a measurement of how much energy being used by a building. This will help encourage buildings to start measuring their energy use, and at least they can get 1 star for doing the calculation. This star rating system then would allow you to have a level of energy efficiency for buildings, which you can then use put to display in your building to show the kind of energy efficiency you have achieved. And it is being endorsed by Suruhanjaya Tenaga. So if you get 1 star, it is highly inefficient. 5 star, most efficient. And the label is the graphic is shown there. Okay. There will be building categories. You cannot compare office to shopping malls. So the category of the building will be stated there, the sort of gray bluish box there, and then the number of the BEI being shown in the red box there. Okay. So if you see this label, that means this building has achieved certain amount of energy efficiency.